We are STEM scholars, and we're here to teach you about the world.
Hi there! Today we're going to learn about bikes, something a little bit closer to home and a little bit farther away from the laboratory.
Biking is cool.
Bikes are cool because they get you places.
Whether you're going to school or work, or enjoying a beautiful evening, or both, bikes are a cool way to get around. Bikes can also take you on great adventures, to the tops of mountains, and even down the other side.
You also don't have to pay for parking, and you don't have to pay for gas. But have you ever wondered why it's so easy to balance on two wheels? You can do all kinds of crazy stuff. But yet when you come to a stop sign, you immediately have to tip over. There's no way you can stay up.
This phenomenon has to do with momentum, and specifically with biking, angular momentum. Look at this coin spinning. Here I'm pointing at the axis of rotation. The metal is spinning around this axis, and since it's already got this motion going, it will continue to do so until another force or torque can change that. This allows the coin to stay upright against the force of gravity. Eventually, when the coin has slowed down some, it has lost angular momentum. It is then less resistant to the force of gravity, which acts to tip it over. Look at how hard it is just to keep this coin upright when it's not spinning. Gravity soon topples it down. It's also stable when you roll it on a different axis, like a wheel.
This is relevant for bicycling because remember, the definition said that it wants to keep rotating about the same axis. And that's what helps you keep up. What I've got here is a bike tire, and it's held on one side by the cord. Now if I let go with my hand, it does what you expect it to, it falls over. But if I get the wheel spinning like this, it stays up.
The amount of angular momentum an object has to do with how quickly it's spinning, as well as its mass distribution, which is known as inertia. In general, a quickly spinning object has more angular momentum than an identical, slowly spinning object. When we take two disc shapes, whose main difference is mass, here's a washer, 8.54 grams, and here's a dime, 2.26 grams. When you set them both spinning at about the same speed, the heavier object can stay up more easily in the face of opposition. We'll look next at another important factor of inertia, which is where the mass is located.
So, in general, if the weight is distributed around the edges of the axis, like in this bike tire, then it has more rotational inertia than if it was the same weight, but it was spread all throughout, or if it was more focused towards the center. This is because the objects on the outside of the radius, or on the outside of the object, have to move farther, faster, than the objects on the inside.
Thanks for watching. I hope you enjoyed and learned something about biking and inertia.